In this video, we will complete the main structure of the two-stage cascade elevator. Build season moves fast, and messy assemblies can turn simple robot changes into hours of CAD cleanup. Let's get started. Using the same methods described earlier, the inline elevator block is inserted into the assembly and positioned within the tube with width mates, as shown in these images, and fully constrained using a concentric mate with the appropriate holes. Again, the choice of mates satisfies the design intent. The same is done on the other side. The last two components are designed to work together with the side tube and the tube plug. The crush block and support plate have hole patterns that match the side tube and the tube plug. Notice in this image, the bolts go through the side plate, side tube, crush block, and into the tube plug. The purpose of the crush block is to prevent the aluminum side tube from being crushed or deformed by forces acting on the side plate. Two width mates center the crush block within the tube, and a single concentric mate aligns the block with the holes in the side tube. The side plate uses two concentric mates, matching the design intent, and a coincident mate secures it to the side tube. All of the mates chosen here match the way the physical components would be put together. The same is done on the other side. The Feature Manager design tree lists the components in the order they were placed into the assembly. You can easily organize similar components together with a simple drag and drop. Now it's time to add some hardware. First, I will click the gear at the top of the interface to launch the System Options dialog. On the Assemblies page, I want to make sure Use AI Fastener Recognition when inserting components is enabled. I will use a design library of components that I have put together previously. See other videos in this playlist to see how to build your own. When I select the hardware folder in the upper panel, the lower panel displays its contents. I will click and drag the bolt I need. In this case, a 10 by 32 1.5-inch button head cap screw. With AI Fastener Recognition turned on, when I move my mouse near a hole it snaps in place. I click to place the bolts needed and right-click after the last one to close the command. Adding hardware cannot be simpler and faster than this. While I am here, I can add more bolts to secure the tube plug. On the Feature Manager design tree, we are starting to get quite a list of components. Hardware can quickly increase the size of this list, making it hard to navigate. To remedy this, I will Shift-select all the added hardware, right-click, and from the context menu choose Add to New Folder. I'll name it Hardware. Now the Feature Manager design tree is neat and tidy. When I add more hardware, like the bolts at the top to secure the inline block, I can click and drag them into the existing hardware folder. The last thing I'll add to this assembly is the bushing for the side plate. I'll add this to the hardware folder too. After adding the rest of the hardware, this assembly is complete. Expanding the hardware folder, it is easy to see the benefit that folders provide in organizing an assembly. Thanks for watching. If your first robotics team is ready to level up, get free SOLIDWORKS Design software, training, and resources to power your team's success, and equip your team with professional tools used by real engineers.